All right, everybody, it's another ChatLoopBackOff. Introduce yourself, and what are we talking about today?
Thank you, George. My name is Koray. I work for Kubernetes as a consultant for the last 4 years. So I work mainly on things around Kubernetes and cloud native technologies. I'm CNCF Ambassador, and also Cube Astronaut, and I do community events or part of the organization of KCD Istanbul, DevOps Days Istanbul, and some other meetups as well. I prefer to talk about the real subject today. Today we'll talk about Kube-OVN. With the social media posts, it was more said like there will be a deep dive on Kube-OVN and deep dive on Kube-OVN and check for a lot of stuff. That's what we are going to try in the next hour. But to set the expectations, I'm not a network expert, I have to say. So there will be things that I don't know very well, but we will go over the documentation and see what Kube-OVN offers. And that's also the idea of this whole ChatLoopBackOff series. A person who does not know the project very well goes through it, see what's there in the documentation, and introduces it to the people. On the other hand, I'm a little bit exposed to Kube-OVN because we use it. One of our products with KubeVirt, but I've never worked on the project or that sort of client already, so I've never used it personally on production environment. So let's see. So Kube-OVN.io is the website for the project, and it is a CNCF Kube-OVN. It's a sandbox maturity level project since 2021, so it's been some time. I hope it will be it will continue with the other levels in the CNCF landscape. So what they say is that it's basically a cloud native network for KubeVirt and multi-tenancy. Especially with multi-tenancy, a lot of issues come up with isolating different tenants from each other. So Kube-OVN offers some solution to that. If we check the features, static IP addresses is one of them. So it simply means that you can assign some static IP address to pods. We might argue that it is not really cloud native thingy. I mean, things should be ephemeral, pods or services should be ephemeral, etc. But especially on on-prem environments, people need such things to have a static IP with with some services. So with host names, it sounds like a little bit old word thing, but yeah, most of the time, especially on-prem, the old world and the cloud native world works together. So there is the VPC support. So that's how you would fix the problems with the multi-tenancy. So each tenant would have their own VPC, just like you are on any cloud environment or cloud provider. VPCs are separated, so it is easier to isolate tenants from each other. You can do pod not NAT, network address translation, and EIP. You can manage the external traffic, like traditional VMs. This is especially useful with KubeVirt while you're running VMs as pods inside your cluster. Subnet isolation, namespace subnets. So each namespace can have its own subnet, which somewhat works with the multi-tenancy. So you would assign a namespace for each tenant, and then they have different subnets. It also supports underlay, which means that your pods can get an IP address directly from your network. So underlaying network. This is, again, I mean, maybe assigning an IP address from the network to a pod might not may not sound like it's needed, but especially with KubeVirt, this is quite important, so that each VM can have an IP address from the underlying network. It supports dual stack, so IP version 4 and version 6 are supported. You can do multi-cluster networking, so you can connect different clusters in one L3 network, which is also nice. It supports network policies. Yeah, it's also a CNI, so it also comes with network policies. You can apply those. It supports dynamic quality of service. You can do traffic monitoring, traffic mirroring. Traffic monitoring replace. Yeah, you can mirror the traffic, and so that duplicate the container network traffic to monitor, diagnose, and replace. It also integrates with Cilium. So yeah, I think we'll see it now with the getting started, but Kube-OVN is actually the CNI, will be the CNI in your cluster, so that when you have it, you can't directly have Cilium as the CNI, but there is also an integration with Cilium, and you can also use the especially security and observability features of Cilium together with Kube-OVN. Yeah, there are some posts here. I think I can just directly go to the documentation. So there is the current release 1.14. It's the stable one, and 1.15 is the dev. So that's also nice. Yeah, let's go over with the overview. It's enterprise level cloud native network orchestration under CNCF, that's we know. And it uses Open Virtual Network and Open vSwitch underlying. So there are two other projects like Open Virtual Network, OVN, but Kube-OVN is the implementation to have it inside your Kubernetes cluster. That's the extra part. Yeah, Kube-OVN brings them into Kubernetes, significantly enhancing Kubernetes' networking capabilities. Why Kube-OVN? Yeah, I think the features was we already talked about this, but yeah, you would have static IP allocation, subnetting, VPC configuration, ACLs, etc., etc., and you can have multi-tenant networks together with, using Kube-OVN. Also the performance there, and yeah. So regarding the CNI selection recommendations, they also documented this part, which is fine. So who should use Kube-OVN, or in which case you should use Kube-OVN? So if you only need an eBPF solution, you can just use Cilium or Calico eBPF. So Kube-OVN uses Open vSwitch as a data plane, and it is relatively older network virtualization technology. So if you just need eBPF and go through use the features coming with it, then you can just choose Cilium or Calico. If you need all-in-one solution like CNI, Ingress, Service Mesh, Observability, everything, I think Cilium is the right choice. They also agree with that. Because Kube-OVN primarily focuses on CNI level networking capabilities. So the rest, like Service Mesh, Observability, etc., is not the core features of Kube-OVN. If you're on OpenShift, then choose OVN Kubernetes. That's another project. If you are using a managed service, managed offering from AWS or Google Cloud or Azure, then just use whatever they provide. So with EKS, AKS, GKE, do not try to use Kube-OVN because, yeah, I think you would have more problems than what you can have. Yeah, for AI training and inference, use host network or host devices and physical devices. So that's another thing. So if you want to have like a high performance, you can use those other tools. So with the concept clarification, so we already said there's OVN, there's OVN Kubernetes, and Kube-OVN. OVN is the virtual network controller maintained by open vSwitch community and providing abstractions for the virtual networking. It is platform agnostic and can offering networking services to multiple cloud management systems such as OpenStack and Kubernetes. So both OVN Kubernetes and Kube-OVN rely on OVN's networking capabilities. So OVN is the main project here, I would say, or the base project that Kube-OVN uses. It's where the name is coming from as well. OVN Kubernetes was initially a project launched by OVN maintainers to provide CNI networking capabilities to Kubernetes using OVN. It's now the default network for OpenShift, and it's widely used in OpenShift environments. So, yeah, we also said that like if you're on OpenShift, you will use OVN Kubernetes, and it seems that it's the default network already. And Kube-OVN was originally developed to address issues like static IP allocation, namespace-based address assignments, etc., using OVN, and here we are. With the community contributions, it has evolved to support advanced features like underlay networking, VPC, and KubeVirt integration. So different projects, different support from the community or different companies, and here we are. So if you're on Kubernetes, if you are not using a managed service or managed offering from a cloud provider, if you are not using OpenShift, you can go with continue with Kube-OVN on your mainly probably on your on-prem environments. Let's go to getting started. How do we use this? So yeah, of course there are some prerequisites. Kubernetes needs to be 129, so it's already end of life. So I think 131 will be end of life soon. 134 is out as of yesterday. So yeah. Docker container, the new versions, also same for CentOS, Ubuntu. Yeah, even relatively old ones. The LTS ones are supported. For other Linux distributions, make sure Gniv, Open vSwitch, IP tables, and IP table not kernel modules exist. So, yeah, if you are using some other Linux distribution, then you need to have those kernel modules enabled on the host. That is the important part. Attention, yeah, there are some bugs and versions that need to be taken care of. Kernel should support IP version 6 because Kube-OVN supports it. Kube proxy works. Kube-OVN can visit Kube API server from Service Cluster API. Boom, boom, boom. Yeah, these options are needed, and make sure no other CNI is installed or has been removed. So that's the important part. When you're creating your cluster, you must create it without any other CNI installed. Yeah, that's the main point. So I think you can do this with Kube-ADM and also others. I will show it with kind today. Yeah, for example, we also have installer called Q1. You can also do the same thing there. Yeah, the important part is that there are some versions that you need to meet, some configuration, and no CNI installed before that. That's the important bit. One-click installation. Dun, dun, dun. Yeah, so this is I think the default is the overlay installation, like a normal CNI, so not using the underlay network. Yeah, there is another documentation for underlay installation. We'll first try with the overlay and see how it works. There is the script installation one, and also there is the Helm chart installation, whichever works for you. But then with Helm, I think you need to provide. Do you need to? Yeah, maybe you need to provide some options. Yeah, I'll go with the script installation because this is I can imagine that because this is up in the list, this is what they prefer. Do they say anything? No, they don't. Okay, let's try to install it. So I have a kind config. I will create a kind cluster with 2 nodes, but this is the important part. I will disable the default CNI. Then we will deploy Kube-OVN. And yeah, with pod subnet and everything, they can change. Kind create cluster. No, that part is wrong. Yeah. And because I've just updated kind and everything, I will have 134 cluster. So it's just new. So, can I get pods? So I do have some pods, but some of them are pending. Can I get nodes? My nodes are not ready. The problem here is that describe pod cube system. Yeah, untolerated because the nodes are not ready yet, so some pods are not running. And then I do need to install. I downloaded it already, but I will do it again. So this is the latest release, latest stable release, installer stage. Let's take a look at it. So there are a lot of configurations. So yeah, for example, for the IP version 6, by default it's false. Well, I also don't want it now. Don't need it. What else? Run user and everything. So the pods, CRDs, and everything is defined here. You can exclude IPs, etc., etc. So after those definitions, okay. So it will simply deploy CRDs and some other stuff, which can also be done with the Helm chart, of course. Install SH. Let's try this. So it first deploys OVN Central. This is a control plane, I guess, and OVS, OVN. These are the CNI pods. I mean, this is similar to what you get when you install Cilium or any other CNI on the system. Pods, and I also want to see nodes. And I hope this will be fast. Let's check meanwhile the documentation is everything. Yeah, so again, if you want to make any changes, you can also do in the script and run it. I didn't do, I just downloaded the script and run it with the default options as they provided. When you're using this to upgrade Kube-OVN scripts, restart all containers, network during an upgrade, this should be skipped or commented from the script. If you're upgrading, you need to skip or comment out step 4 because you don't want to restart all container network ports. If any parameters were just during Kube-OVN, these changes must be updated in the script before upgrading, of course. So you downloaded the script, you deployed this version, a new version, you again download the script. You need to make those changes again, otherwise you'll have issues. It's of course, in that case, it might make more sense to use Helm and maybe with Argo or Flux with GitOps approach to, then you would have the same Helm values somewhere, so that things would work easier. One of them is now running. That's promising. So I guess the others will run soon. And when the nodes are ready, I think this local path and core DNS pods will also start running. Yeah. Things are moving now. Yeah, and more coming by. So Kube-OVN CNI. Okay, the CNI is now this one. These are the OVM pods. So switch, and then the Kube-OVN part is being deployed. Okay. Yeah, so when the CNIs are deployed, then the nodes become ready, and now local path running, core DNS, everything is running now, except controller monitor, OVM pinger. Yeah, I think now I have a good running cluster. Let's see what's happening here. Okay, now more things. Oh, it even tested something. Created, yeah, okay. Yeah, it looks good. So now we have the CNI installed and Kube-OVN is running. That's great. Thanks for choosing Kube-OVN. Sure. Nice. So we have a cluster now. It's deployed. We have the CNI or Kube-OVN running. There are some other things. So there is the underlay installation. Let's check what's happening here. Or maybe we can check the underlay later on. I don't want to I want to continue a little bit. Talos Linux, you can do some other stuff, and for install, they provide a cleanup sh, or yeah, you can do ham uninstall. That's fine. Okay, let's go to the user guide. So installation configuration, I think we've already done with the installation. Yeah, you can of course config MTUs and everything, just like any other CNI. You can configure those stuff. LB settings, network policy settings, enable. Oh, was it at enable NP? Okay, so network policies are by default enabled. Load balancer. Load balancer true. Okay, nice. So these were by default enabled. Yeah, you can do a lot of stuff. Yeah, with Kubert. Yeah, we'll come to that. Config subnet. So at the very beginning, we said that you can have different subnets configured so that you can use the multi-tenancy. Let's see if there is an example here. Check the default subnet. Okay, let's maybe we can first check the get crd grep OVN. Okay. So with Kube-OVN, IP pools, IPs, IP tables, DNOT rules, FIP, SNOT, OVN stuff, provider networks, QoS policies, subnets, here, Kube-OVN, switch LB rules, VIPs, VLANs. Yeah, these are the things that we can actually define or configure using Kube-OVN. I think that's an important one. So yeah, let's check the default subnet. What is it? Oh, yeah, we have the OVN default subnet. CRDR block is this. Get pod dash a dash white. Yeah, the daemon sets get it differently, but you see it's 10.16.0 network, which is defined here 10.16.01, right? 10.16.0. And if I check the kind, Kubo, no, maybe it was here. So in my pod subnet in the kind cluster, when I first creating it, I defined the pod subnet as 10.224.244. But as you see, the default subnet is configured as 10.16.0 network. So the pods get this one directly. So it is overridden by Kube-OVN. This is also another important topic. So whenever, after you install it, it installs a default subnet, and the pods are created in this default subnet. So in the Kubernetes network specification, it is required that nodes can communicate directly with all pods. So yeah, we know that especially for the node port services and the others. So each host needs to communicate with the pods running on the other nodes. So this also requires some sort of subnet. And for that, Kube-OVN also creates a subnet called join. By default, I did not create it. And here you see there is a join network, subnet, and it is 164.01 private nodes. Wondering. Yeah, okay, these are not there, but this is another subnet that is now part of the whole virtual switch stuff. And this join network is used to make sure that nodes can communicate with pods running on other nodes. Does Kubernetes use the host network to keep in touch with the API server? I'm doing CNI replacement. Does the kubelet use the host networking to keep in touch with the API server? Yeah, I believe so. And yeah, also Dinesh said the same thing. Yeah, that's it uses from the host networking. OVN at the node. Yeah, we can also do that. Let me go to one of the the worker node. IPA. Oh, there's a lot. There is this OVS system and OVN 0. So as you see, this OVN 0 on the, so I'm on the host. Well, it's a Docker container because this is a kind cluster, but yeah, this is the host itself, and it has an interface called OVN 0, and it has this IP address. This is the join network, if you remember. And where is the 10 network? Is it here? So this is the ETH0. This is the host IP address, so it's here. This is this is the IP address when you check kubectl get nodes. This is the IP address, and I guess this join network also has connection to the default network and the others. Yeah, probably it's part of the OVN configuration. So when the host has access to this join network, where was it? I can't see it anymore. Where's OVN? Here. When it has this access to this network, this is the join network that we just checked. It has access to the pods on the other nodes as well. Boom, boom. Yeah, console is a shortcut, but it just creates a pod with how do you say, with privilege things on a node, and then I have access to the node itself. So let's create some custom subnets. So we can create a subnet. So it says that this is a new subnet called subnet 1. IP version 4. It has a different CRDR block, and it excludes some IP addresses. So from 1 to 10 and from 101 to 151. The gateway is this. Gateway type is distributed. I actually don't know what those means here for this one. Route table is empty, and for namespaces it's NS1 and NS2. So yeah, I've read the documentation before a little bit, but so that means whenever you create a pod in NS1 or NS2 namespaces, they will be part of subnet 1. That's the catch here. So again, if you think about multi-tenancy, then things get quite easy here. You probably already have namespaces per tenancy. So if you say that, okay, this subnet is for this namespace, and this namespace is your tenant, your client, your customer, your department within a company, whatever you are doing the multi-tenancy, you can just separate their networking this way. Exclude IPs next to route table. So yeah, the default is main table, but you can also create some static routes for this namespace as well. Boom, boom, boom. Exclude IPs, yeah. So I think obvious. Yeah, these are obvious. Let's create this one. Okay, get subnet. So, oh, nice. We have now sorry. So we have 3 subnets now. The join and OVN default we know, and this is subnet 1. It's provider VPC OVN cluster. It's VLAN OVN cluster, I guess. Let me make it a bit smaller. Yeah, VLAN is empty protocol IPv4 CRDR. Yeah, we know those. The not is true. Default, so it's not default for sure. Gateway type distributed. Version 6 use 0. We don't use version 6 at all, and exclude IPs. Is it the same? No. Is it the same? I think so, yeah. Okay. So we have a new subnet. So workload subnet binding. Okay. So by default, pods will be assigned IP addresses from the subnet belonging to the namespace. I think I said this one before. Right now, I mean, if we create a pod in NS1 or NS2 namespaces, they will be part of this subnet one. If a specific subnet needs to be specified for the workload, it can be achieved by setting the pod's annotation. So this one is created on default namespace, and then but we want to say that we want it to be used by or part of subnet 1. That is, I think, also so target pods. So I have a pod on this is the default namespace. Sorry. Dash override. As you see, it got this 10.66 IP address, which is the subnet. This is the subnet 1. So that is the one thing, and the other is that okay. I think I don't have those anymore. Create NS1. Okay. Current. No. Create. So I want to have this port again, but I want to create in the namespace NS1. Subnet test. I don't know. Right, put in. Right. So this one is also in the NS1 namespace. This time I did not provide the annotation, but because it's in the NS1 namespace, it gets this 10.66. Another one, maybe if I say NS3, create NS3. So this time it is a namespace which we did not this time it gets 1016. So this is now part of the default subnet, because I did not put any annotation. In the subnet configuration, I did not give NS3 as the namespace to use. So it is created on the default subnet. It seems that I spent a lot of time with this, but yeah, I think this subnetting is the important part. Yeah, also here with especially for the isolation part, you can say that, yeah, only allow subnets from these. So this one is created on 1069 and it only allows from the default, and I think 1018 is, yeah, we didn't define. So this way it's only allowed from some specific subnets, but not all of them. When you create the subnet with this YAML file, then it configures the switch, and then the switch do not have the routes to connect those subnets. That's the main idea. There are a lot of configurations. I would like to go through the documentation a bit more. So dual stack, yeah, we know that yeah, if you provide both IPv4 and IPv6, then it becomes dual stack. That's the important part. But then you need to assign those variables as well, or during the installation, like with the Helm chart or the install sh, you need to provide the pod CRDRs. And when you check the pods, you will see it will have 2 IP addresses. That's great. Fixed addresses, I think that is an important one. So here, this is a deployment. This is called IP pool. Yeah, it runs an Nginx container, and then so replicas 2, and it will get an IP from this pool. So I think that also makes sense a little bit, because when you have a deployment, if you provide only one IP, then you can have only one replica with that IP, of course. But if you will have multiple replicas, then you provide an IP pool so that the Kube-OVN controller will select which one to assign to this container. I don't want to do all of them on the cluster right now, because it takes time and we don't have much time. I want to talk a bit more with other stuff. I think especially, the stateful set itself is for having some sort of static, at least static DNS names within the cluster. And using Kube-OVN, you can also assign static IP addresses as well. That's also a nice one. Here, how does it work? I don't see any configuration. Stable supports fixed IP by default. You can use IP pool. Yeah. Yeah, okay. And for the stateful set, the IP pool addresses are assigned in order. So pod 0 will get the first IP, pod 1 will get the second, pod 2 will get the third, etc., etc. How many IP addresses you have. And for KubeVirt VMs, I think it's the same thing. So they're eventually pods running inside the Kubernetes cluster. Reserved IP for specific resources. So, okay, you can also reserve IP addresses. Yeah, you can there is a kind IP. I think we saw it with when checking the CDRs. CDRs. No, CRDs. Yeah, you can reserve or allocate some IP addresses in advance, which is also a cool thing, especially if you're working with KubeVirt. You assign IP here. Okay, that's how do you assign it to a pod? Pod type. Okay. You define this. You also define it with the pod name. So whenever there is this pod name starting up, then it will get this IP address. So yeah, I think it's a nice one. You don't need to do anything on your pod side or deployment side. It gets the IP directly from the reservation, which is also nice. Yeah, you can configure IP pools. Yeah, also custom routes with gateways, destinations. So for specific destination, use this gateway, etc., etc. You know, these are the basic networking stuff. Yeah, I think these are more advanced SNOT than the others. You can check the documentation here. I can't go over all of those, but things simply work with some annotations. So if you annotate your pods with some specific values, then you can get IP addresses for SNOT and the others. That's also nice. You can manage quality of service, so you can actually assign some bandwidth limits. I think that could also be useful for, especially for multi-tenancy, because yeah, let's say if you have both test and prod environment together, or if some clients, or I don't want to say some clients, but some tenants are more important than the others because of this and that. Yeah, you can also define quality of service for those. I mean, inside the network using Kube-OVN. That's an important one. Webhook, Stack Manager and stuff. Okay. Nice. I think, yeah, you can mirror the traffic. So that would also be important in some cases, maybe. I don't know. Yeah, there are some performance tests here. So with the mirroring, UDP bandwidth, TCP bandwidth is 164 gigabits, 269 gigabits, etc. Yeah, it's of course not as good as without the mirroring, but I think it's not too bad, I guess. Different nodes, yeah. You can just check those documentation, but there are stuff that can be done here as well. And you can also log the network policies. That's, I think, important because I think the main problem I see with network policies is that packages are dropped and you have no idea what happens. Sometimes, I mean, for me, it's a challenge to understand that, yeah, things are not working because of a network policy.
10-minute warning.
Okay,
Sorry.
thanks, George. Yeah, no worries. Yeah, I'm also aware. So yeah, the logging is also, I think, an important feature, so that you can see, first of all, you can see who is trying to reach where, and if something is not working, you can also debug it from the logging. Load balancer type service, monitor dashboard, etc., etc. There are more. I also want to talk a little bit about KubeVirt because I think this is important. Nowadays, people are looking for ways to looking for alternatives to VMware or maybe some other tools, because I mean, cost saving mainly, because yeah, Kubernetes is like a open source project, and yeah, you can use it. But with Kube-OVN together, having fixed virtual machine addresses is, I think, an important feature, because yeah, when you have a VM, when you give it to some people to use it, then the IP address should be first accessible, and also should be probably the same if they are deploying their services on that VM. So that part is important. I will check. So this is the obviously KubeVirt part. This has nothing to do with Kube-OVN right now, but the important part is here where do we set the networking? Domain, blah blah blah, networks default. Okay, port network. So I think this one, this is for the live migration. Yeah, okay, the specifying the IP address. So again, the same thing. So because this virtual machine eventually will create a pod, and I think this is the same annotation that you use with the pods. You provide the IP address here, and yeah, that's the main part. So when you are creating the virtual machine on KubeVirt, you can directly put the IP address here from that subnet, and it will be used by the VM created by KubeVirt. So it will also have the live migration and the other stuff with KubeVirt. So there is an integration, and I think it is important. I will just go through some stuff. So there are yeah, you can also have internal DNS. The core DNS deployed VPC cannot be accessed from custom VPC. Okay. Yeah, you can do some of stuff, and you can also obviously do some VPC peering. So you create two. I mean, this one creates two VPCs and two subnets on each one, and then yeah, with the VPC, there is this VPC peering configuration, so you can peer those VPCs just like you do it on a cloud offering. Something similar. Yeah, obviously Kube-OVN brings a lot of features to your Kubernetes network or Kubernetes cluster. There are a lot of advanced features here, like yeah, you can have multiple interfaces configured, which makes sense, especially for high availability. Yeah, there is BGP support. I think this is also important stuff for some people. If you're using BGP network, there's also the BGP support. It also supports MetalLB to get a load balancer, or sorry, to get IP addresses from the underlying network. And yeah, the Cilium thing, I also, yeah, integration with Cilium, I also wanted to show this one. So you set network policies to false and CNI config priority to on, so 10. So this is the important part. And then you deploy Cilium, but with generic VETH mode. That is, I think, the important bit to check. And then you can use Cilium as, I mean, the features like the security and the monitoring features of Cilium together with Kube-OVN. There is a lot of things. I mean, this is what I can talk about in an hour, and I tried to show basic operations with Kube-OVN here. I think things was, yeah. I hope this was a nice introduction to everyone who haven't used it, and I think it's a very good option to have it on your on-prem clusters as the networking stack.
Yeah, it's interesting because you were concerned that you weren't gonna take up the whole hour. Everybody
I did.
Yeah. All right. Well, thank you very much. We'll see everybody next week. We're gonna go ahead and wrap this up. You get the last word though. So
Well, I hope this was informative for people, and more people can start using it. That's all I can say at the moment.
all right.
The direct questions, I think the questions are answered already. Yeah, okay. Cool.
Yep. All right. Thank you very much. We'll see you all next time. Thanks
Thanks
man.
for having me.